Hi, let us evaluate this integral 0 to pi dx by 5 plus 3 cos x whole power 4. Right? Let us take 3 as common in the denominator, then it will be 1 by 3 power 4 is 81. Then it will be integral 0 to pi dx by, let us assume it as a plus cos x. Here a is 5 by 3. Right? Then this will be 1 by 81 into uh, see here, actually it is in the form of 1 by x power 4. If you differentiate 1 by x, then it will be minus 1 by x square. If you differentiate twice, it will be x cube, 1 by x cube. There will be factor 2. Similarly, if it is a plus cos power 4, then it might have got derived 3 times. Right? Integral 0 to pi dx by a plus cos x. Here a is 5 by 3. Fine. So let us calculate this integral. Let us make it as equation 1. So integral 0 to pi dx by a plus cos x with a is greater than 1. Right? Then how will you do it? Let's proceed in a way. Let's try to make some substitutions here. Let's make a substitution. X tends to pi by 2 minus x. Right? If x tends to pi by 2 minus x, then dx will change to minus dx. X equal to 0 then changes to x equal to pi by 2, then x equal to pi changes to x equal to pi by 2 minus pi, it will be minus pi by 2. Then this integration will turn into 0, turn into pi by 2, pi turned into minus pi by 2, dx turned into minus dx by a plus cos of x is pi by 2 minus x. Because of this negative sign, we can interchange the lower and upper limits, as it is minus pi by 2 dx by a plus cos 90 minus x is sin x. Right? Let us assume it as I prime. Right? Then I prime is minus pi by 2 to, let's write it down here, I px by a plus sin x. As you know, integral a to b f of x dx is, you can write f of a plus b minus x dx, right? Then you can write it as minus pi by 2 into pi by 2 dx by a, right? Sine of minus pi by 2 plus pi by 2 minus of x. Then it will be sine of minus x minus sine of minus x is minus sine x dx. So these both are equal. If you add these both, right? If you add these both, then it will be just like 2I prime equal to minus pi by 2 to pi by 2 1 by a plus sin x plus 1 by a minus sin x dx. 2 I prime equal to minus pi by 2 to pi by 2, then this will be, denominator will be a square minus sine square x, this will be a minus sine x plus a plus sine x dx. This sine x will get cancelled and this will be integral minus pi by 2 to pi by 2 2a by a square minus sine square x dx. This 2 will get cancelled here. Then I prime is minus pi by 2 to pi by 2 a dx by a square minus sine square x, right? As you can see here, because of sine square x, then even sine of minus x will be sine x because of the square term. Then you can write it as 2 times of 2a 0 to pi by 2 dx by a square minus sine square x, right? That is I prime equal to 2a into 0 of 0 to pi by 2. Let's do one thing. I mean, divide the numerator and denominator by cos x. Then it will be secant square x dx by a secant square x minus sine square x by cos square x will be tan square x, right? This will be tan square x. This can be written, let us write, I mean, denominator in tan form. 2a integral 0 to pi by 2 secant square x dx by, so here it's a square, right? Yeah, a square by secant square, a square into secant square x is 1 plus tan square x minus tan square x. Then this will give rise to I prime equal to 2a into integral of 0 to pi by 2 secant square x dx by, if you take common tan square, then it will be a square minus 1 tan square x plus a square, right? Then the next step is, let's do one thing here. 2a, this 2a, right? Let's take fine 0 to pi by 2 secant square x dx by, let's take a common in the denominator, then it will be, if you take a square as common, then it will be 2a into 1 by a square 1 minus a power minus 2, right? Tan square x plus 1. This is I prime plus I prime equal to 2a into 1 by a square. Let us multiply and divide with 1 by root of 1 minus a power minus 2. If you are multiplying and dividing with this term, root of 1 minus a power minus 2 secant square x dx by, let's write this in similar form, 1 minus a power minus 2 tan x, right? Whole square plus 1. Then we need to evaluate these terms first. Let us make this as I double prime. I double prime equal to integral 0 to pi by 2 root of 1 minus a power minus 2 secant square x dx by root of 1 minus a power minus 2 tan x whole square plus 1, right? Then how will you proceed this? You can just use simple trigonometric equations like let's take u is tan x, then du will be secant square x dx. If x equal to 0, then u equal to 0 because tan 0 is 0. If x equal to pi by 2, that implies u equal to infinity because tan 90 is infinity, right? Yeah. Then this integral I double prime becomes u equal to 0 to infinity root of 1 minus a power minus 2 secant square x dx is du, right? Du by root of 1 minus a power minus 2 tan x is u, this whole square plus 1, which will be equal to integral 0 to infinity root of 1 minus a power minus 2 du by 1 minus a power minus 2 here u square plus 1. Let's write it again here so that it will be easier. Root of 1 minus a power minus 2 du by 1 minus a power minus 2 u square plus 1. Let's make a substitution here even. Let's say it's b square as 1 minus a power minus 2. Here a square is greater than 1, then b square must be greater than 0, right? Fine, that will be fine. Then there will be no imaginary part from there. Then I double prime equal to, which will be you can see the limits won't change. I mean, let's make substitution here first, right? Let's write it down here 0 to infinity. This will be b part, b du by 1 minus a square b square u square plus 1, right? Now let's make a substitution here. Let's make bu equal to v, then du du equal to dv, right? If u equal to 0, that implies v equal to 0. If u equal to infinity, v equal to infinity. That means integral limits are not going to change, which will be I double dash equal to integral 0 to infinity b du is dv. V square is v square plus 1, which is nothing but dv by v square plus 1 square, right? It will be tan inverse v, which is 0 to infinity, which is nothing but pi by 2 minus 0 equal to pi by 2. That means we got I double prime equal to pi by 2, right? Then I double prime equal to pi by 2. Then from I prime, this equation, let us consider it as 2. From 2, I prime equal to 2a into 1 by a square into 1 by root of 1 minus a power minus 2 into this I double dash. I double dash part is pi by 2. These two will get cancelled, and this a will get cancelled. That is I prime equal to pi by a into 1 by root of 1 minus 1 by a square, right? It will be pi by a into a by root of a square minus 1. It is pi by root of a square minus 1. I prime is pi by root of a square minus 1. So from equation 1, which we have substituted here, this formula, right? 1 by 81 of minus 6. So what we need to do is integral 0 to pi dx by 5 plus 3 cos x whole power 4, right, is equal to minus pi by 486. That is 81 into 6, right? Then there is a d cube by d a cube of this part, a square minus 1 whole power minus 2, where a is 5 by 3. After differentiating 3 times, you will get it as 1 by 162 into 2a cube plus 3 by a square minus 1 into 7 by 2 pi, where a is 5 by 3. Ultimately, you will get, after substituting the value of a, dx by 5 plus 3 cos x whole power 4 is equal to 385 by 32768 pi. This is the final result.